Hi, my name is Pratik Sachdeva, and I'm a postdoc at the Social Science Data Laboratory at UC Berkeley. I'll be speaking about our work to assess annotator identity sensitivity with item response theory in a hate speech corpus. This work was conducted with my co-first author, Renata Barreto, along with Claudia von Vacano and Chris Kennedy. A content warning. We will have a couple slides which use example comments that are hateful and use slurs. The slurs will be censored. Annotators are critical in machine learning at large. They provide the labels to data sets from which algorithms are able to learn the underlying patterns. However, their role in machine learning has long been underappreciated. For example, Denton et al. Comments on the annotators for ImageNet, of whom little is known, such as their compensation, country of origin, and demographic characteristics. It's important that we more seriously consider the perspectives and experiences of annotators, since they play an important role in shaping machine learning pipelines with real-life consequences. This is particularly evident on subjective tasks such as hate speech detection, where not all annotators agree on what is or isn't hate speech. This, among other sources, can manifest as racial bias, which has been previously observed in hate speech detection algorithms. Annotator perspective can influence the labels they assign to data samples on tasks such as hate speech classification. One could view this as annotator bias. However, in this work, we're going to shift away from that perspective for a few reasons. For one, there's no clear ground truth in many NLP labeling tasks. Using the term bias is problematic, particularly when most annotator pools do not adequately reflect the general population. We further try to avoid conflating different connotations of bias, such as statistical, implicit, or social biases. We're instead going to use the term annotator sensitivity. So, greater sensitivity to a comment implies that the annotator is more likely to assign a specific label on a data sample. This will become more clear when we define it in the hate speech context. Sensitivity brings with its own set of norms and assumptions, some of which might be negative. However, we see sensitivity as a strength when it serves to uplift minoritized communities in the face of algorithmic oppression. At the same time, we reject annotator sensitivity favorable toward white supremacy and aim for our methods to facilitate interventions in these scenarios. So our goal in this work is to quantify annotator sensitivity in a hate speech corpus. Specifically, we aim to quantify how an annotator's identity, shaped by lived experience, their values, and others, influence their labeling patterns in a hate speech corpus. In this context, then, greater sensitivity to a comment implies the annotator is more likely to label it as possessing aspects of hate speech. To do so, we're going to use the item response theory, or IRT, which is a paradigm in measurement theory used to measure latent attributes. Using IRT requires a specific data set specifically designed to facilitate its analyses. The one we'll use is called the Measuring Hate Speech Corpus, which is available on Hugging Face. It's created by my co-authors, Chris Kennedy and Claudia von Vacano, and others. The dataset consists of over 50,000 social media comments across 3 social media platforms, labeled by over 10,000 annotators. The annotations consist of 5-level Likert scale ratings on 10 survey items, which span different concepts of hate speech. Importantly, the dataset includes demographic information about both the target of the comment, which group or identity the comment is aimed toward, and the demographic information about the annotators. This information is critical to our analyses. Before we dive into our results, I want to talk a little bit about the underpinnings of IRT. IRT's goal is to develop a measurement scale, in this case, a continuous scale for hate speech. To do so, one needs to first theorize a construct of that scale. Kennedy et al. Used qualitative analyses to theorize the following spectrum, ranging from supportive to neutral to hostile and to genocidal speech, which they characterize as the most hateful. Next, one needs to develop survey items, different labeling tasks in order to probe the comments along their placement along the theorization. Some of these survey items match directly with the theorization, such as violence or genocide, but in some cases, we need additional survey items to more finely probe the construct levels. We have 10 available survey items in this data set. Then annotators label each sample according to the 10 survey items on a Likert scale. The ordinal scale allows annotators to provide more detail in their responses. Finally, the scaling procedure, the fitting of an IRT model, allows us to develop the hate speech spectrum, which is provided by the IRT model parameters. Let's dive deeper into the IRT model, since it's the starting point for the methods we develop in this work. The model we use, a faceted IRT model, incorporates multiple components in the generation of a label via a latent variable probabilistic model. Specifically, we're modeling the odds ratio, the probability that annotator J for survey item I and comment N assigns a rating K relative to rating K minus 1. This may pertain to, for example, strongly agree versus agree. We can think of this in the current context as, what are the odds I deem this comment to more strongly exhibit an aspect of hate speech? This is going to depend on several components. For example, the ability of a comment. Its inherent hatefulness is obviously important for assigning the rating. The survey items matter too. This is captured by the difficulty. You likely have different thresholds for the genocidal survey item versus the bias survey item. Of most interest to this work is the severity, which captures the internal threshold of annotators and their strictness or leniency in assigning labels. Lastly, a term captures the difficulty of the ordinal response. Some ordinal responses may be more disjointed than others. Now that we have some basics of the IRT model set aside, let's set up the problem. To motivate the problem, we're going to take a look at annotator responses to a comment that targets Black women. We examine labels by two annotator pools, Black and white annotators, which were the largest racial identities represented in the dataset. We look at the ordinal ratings for some of the survey items and normalize them so that their maximum is 1. All scales are oriented so that higher rating corresponds to a higher degree of hatefulness. We found that Black annotators tended to find this comment more disrespectful, insulting, and humiliating. They were also more likely to characterize the comment as hate speech. However, both annotator groups generally agreed on the violence expressed by the comment. In another example, we have a comment targeting women. We examined annotators identifying as men and women. We omit non-binary annotators because they were not enough to perform a statistical comparison. And we find that men and women generally agree that the comment is not hate speech. However, women find the comment more disrespectful, more insulting, and more humiliating than men. So annotator identity clearly aligns with observable differences in rating patterns. Those differences seem to correspond by who is targeted by the comment. In this context, we might say that Black annotators and annotators identifying as women expressed higher sensitivity in rating these respective comments. Let's think about this a little bit more broadly. Who are the communities impacted by a hate speech classifier? 3 stakeholder identities intersect to influence what the classifier learns: the comment's author, the target of the comment, and the annotator. In our data set, we only have access to the annotator identity and the target identity. So we're going to aim to use our IRT methods to characterize annotator identity sensitivity as a function of the comment's target. We use 3 different IRT approaches to characterize annotator identity sensitivity. For brevity, in this talk, we're going to highlight 2. The first is called separated measurements. In this approach, we split up the comments into 2 subcorpora. We then look at the annotator responses to each subcorpus and fit an IRT model to each. This produces 2 sets of IRT parameters, including the severity parameters. Each annotator will have a pair of severity parameters, which allows us to assess how their labeling patterns differ on the 2 subcorpora. So if an annotator is less sensitive when comments target a specific population, we can ascertain it by comparing their severity values. To make this more concrete, we're going to perform separated measurements on comments targeting Black and white folks. This is not to imply that Black and white folks are historically equally situated targets of hate speech, but these 2 pools were the largest in the data set, providing us the largest statistical power in our analysis. We define a quantity called the annotator lean, the difference in severity estimates on a separated measurements for Black and white targeting comments. In this context, if the quantity is greater than 0, the annotator is more sensitive to comments targeting Black folks. If it's less than 0, the annotator is more sensitive to comments targeting white folks. We calculated annotator leans across the population of annotators. We compared the annotator leans for Black and white annotators, finding that Black annotators as a group had a significantly higher annotator lean compared to white annotators. This implies that Black annotators were more sensitive to comments targeting Black folks, and white annotators were more sensitive to comments targeting white folks. Because the IRT parameters relate to log odds, we can recast the annotator lean in this context. Thus, Black annotators were around 1.4 times more likely to label comments targeting Black folks as exhibiting aspects of hate speech, whereas white annotators were 0.97 times as likely. That is, they were less likely. We then examined the change in odds ratio suggested by the annotator lean across a wide range of annotator identities. We considered political ideology, religious affiliation, gender identity, sexual orientation, income, and education. We found that Black annotators, liberal annotators, non-religious annotators, women, queer annotators, all exhibited higher sensitivity towards comments targeting Black folks. On the other hand, conservative annotators, Christian annotators, men, and straight annotators exhibited significantly higher sensitivity towards comments targeting white folks. We found no statistically strong patterns by income or education level. Separated measurements only allowed us to compare two subcorpora. However, comments target a wide range of racial identities. To allow for a group level comparison, we considered an approach where we extended the IRT model to allow for an interaction term. This interaction term can be thought of as an adjustment to the odds ratio as a function of target identity and annotator identity. We refit the IRT model to the entire data set with this interaction term, considering all racial identities available: white, Black, Latinx, Asian, Middle Eastern, Native American, Pacific Islander, and an other racial identity. We found that group level interaction terms reveal sensitivity to our annotator's own racial identity. Specifically, white, Black, Asian, and Middle Eastern annotators exhibited significantly higher sensitivity towards comments targeting their own racial identity. The remaining annotator groups did not exhibit significant results, but this may stem from lower sample sizes. To conclude, we provide three methods, highlighting in this talk two of them, to assess annotator identity sensitivity in machine learning datasets. In a hate speech corpus, we identify a relationship between an annotator identity and their sensitivity towards hate speech. Specifically, we found that annotators tended to exhibit more sensitivity in rating elements of hate speech when the speech targets a group that they identify with. Our work has some limitations. For one, our analysis is incomplete. We lack information about the comment's author. Annotators may exhibit different sensitivity when comment authors are of a particular identity group, particularly if the annotator can infer the identity group from the comment. Second, our annotator pool consisted largely of white annotators. The imbalance between demographic groups shifts the meaning of the severity parameter. This implies that severities are implicitly compared to white annotators. Future work could investigate reweighting sensitivities according to the empirical demographic distribution so that minoritized groups have a larger impact on the parameter estimates. In this work, we only consider the training data, but it's important to consider how these effects manifest in trained machine learning models. And we leave that for future work. We mainly considered racial identity in this talk. Our paper highlights additional experiments on gender identity and sexual orientation. However, annotators are not defined by a single identity. It's important to consider intersectionality in future work. Specifically, comparing the overlap between different identity groups in these types of analyses is important. Lastly, annotators provided the labels we use for specifying the targets of comments. Given the annotator sensitivities we observed, annotators may exhibit similar patterns on the task of identifying targets. Thus, future work should more deeply consider when target identification is modulated by annotator identity. Lastly, we want to thank our colleagues Aniket Kasari, Jeff Bacon, and Alexander San for their support, and we want to thank you for listening.